Hello everyone, welcome to In 5 Minutes. In this video we are going to see the next problem on gamma function type 1. So before that, what is a gamma function? Gamma function is given by gamma of n equal to 0 to infinity e raised to minus x raised to n minus 1 into dx. Here it is n and here it is n minus 1. So this is the basic formula of gamma n, and in type 1 we are given the equation is of the form 0 to infinity e raised to minus a x raised to m x raised to n dx. Okay, then we substitute this term equal to some another variable and then we solve and we try to make our equation in this form. Okay, so remember, in any problem of gamma function we have to make the given equation in this form only, then only we can apply the gamma function. Okay, so this is our question. Solve this term. So if you see here we have e raised to minus 3x square and here we only want minus x. Okay, and these two terms are matching, so it is of the type 1. So what we are going to do, we are going to just substitute this term equal to some another variable. Let's say we put 3x square equal to t. Then we take the derivative. Then we write x equal to something, that is x square is t by 3. Then x will be root t upon root 3. Then we take dx derivative. So derivative of t raised to half is nothing but t raised to minus half, and root 3 will remain upon 2 into root 3 dt. So this is the derivative of this term. So after this, our limits of integration will also change. For that we will draw one table. Here we will write x initial variable, here we will write new variable which is t. So here x is 0 and here x is infinity. When we put x equal to 0 in this equation, we get t equal to 0, and we put x equal to infinity, this whole term will become infinity and t is also infinity. Now our new equation will become I equal to 0 to infinity, this is for t equal to 0, then into x square. What is x square? From this term, x square is t by 3 minus 4 the whole square into e raised to minus 3x square. We are putting 3x square as t. So e raised to minus t. What is dx? Dx we have calculated here, which is t raised to minus half upon 2 root 3 into dt. After this, if you see in this equation, all the terms are here and there. We have to make our equation in this form, where we have e raised to minus 1 variable, that is x. Here we have t, x raised to n minus 1. Here we want t raised to something. Okay, so we have to make our equation in this form. So consider this equation. So 2 into root 3 is constant, so we can take 2 into root 3 outside the integration. Then we have these three terms. First we will expand this term, so 0 to infinity integration will remain as it is. T by 3 minus 4 the whole square is similar to a minus b the whole square, which states that a square minus 2ab plus b square, that is 4 square, is 16. E raised to minus t and t raised to minus half dt will remain as it is. Then we have 1 upon 2 root 3 integration of 0 to infinity. T square by 9 will remain as it is, minus 2 into 4 become 8, and upon 3 into t plus 16 e raised to minus t, t raised to minus half dt. Now we want e raised to something and x raised to something. Here instead of x we have t. So we are going to multiply this three term inside the bracket. So just observe what we get. So here we have t square upon 9 into this whole term, which is e raised to minus t, t raised to minus half dt, and I am taking this integration sign with each term. Okay, minus integration of 0 to infinity 8 upon 3 into this t into this whole term, which is e raised to minus t, t raised to minus half dt. Then we have plus integration of 0 to infinity 16 into this term, which is e raised to minus t, t raised to minus half dt, the whole bracket, and outside we have this term.